Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you feeling today? I hope you are feeling good. In this session, you will be with me. I am Ni Adewati from SMK Taman Jasmine 2. Today, we will learn about heat. Boys and girls, on this table here, I have a bowl of boiled spaghetti that is still hot. Where does the heat come from to cook this spaghetti? Yes, it comes from a gas stove. Can you list other sources of heat? Good. Heat is obtained from the sun, electrical appliances, and also burning of fuels. In this topic, we are going to learn about 1. Temperature and heat. 2. Heat flow and thermal equilibrium. And 3. Principle of expansion and contraction of matter. By the end of today's lesson, you should be able to make a comparison between heat and temperature. Explain how heat flows from a hot region to a cold region. Explain and communicate about heat flow in natural phenomena. Communicate about heat conductors and heat insulators and their uses in daily life. Explain how heat can cause the expansion and contraction in solid, liquid, and gas. And communicate about the various uses of expansion and contraction of matter in daily life. Okay pupils, what is meant by heat? Heat is a form of energy. Heat flows from a hotter region to a colder region. And how about temperature? Can anyone tell me? Yes, correct. Temperature is a measure of degree of hotness or coolness of an object. Now, let's discuss the differences between heat and temperature. Pupils, take a look at the table here and let's discuss together. As far as we know, heat is a form of energy while temperature is the measurement of hotness and coolness of an object. Heat is measured by joule and the unit is the capital letter J, while temperature is measured in degrees Celsius or Kelvin. The amount of heat depends on the types of material, quantity of material, and temperature, whereas the amount of temperature depends on the degree of movement of the particles in a matter. We must know these terms and understand them. Let's dig it. We can start with temperature. Like the temperature outside today, it might be hot or cold. But in science, we want to quantify everything. So when we say something is hot or cold, just isn't enough. We want to be able to say how hot or cold with numbers. But that begs the question, how is the temperature physically measured? Temperature is measured in Celsius, Kelvin, and Fahrenheit, while heat, which is another type of energy, is measured in joule. Now, boys and girls, let us learn about the flow of heat. Let us imagine ice cream at room temperature. Why does ice cream melt when we leave it for several minutes? Well, peoples, this is because the ice cream absorbs heat and this causes it to melt. How about the hot kettle? What would happen when we leave it at room temperature? Yes, the hot kettle will become colder. This is because the hot kettle releases heat into the surrounding and becomes cold. So, the conclusion for this situation is that heat flows from a hot object to a cold object. Pupils, do you know how heat flows? Heat flows in three ways, which are conduction, convection, and radiation. Let us study the slides after this to understand these three ways of heat flow. First, heat that flows through a conductor is called conduction of heat. Conduction is the process of heat transfer from hotter regions to colder regions through a solid medium. The particles that receive heat energy will vibrate and collide with one another more frequently and transfer the heat to the whole medium. Can you try to name a few examples of conductors? These are the examples of conductors. They are silver, gold, copper, and steel. Do you have your own examples? Second, heat can also be transferred by convection. Heat is transferred by movement of fluid, which are liquid and gas, from hotter regions to colder regions. The part of the fluid that receives heat will expand, become less dense and rise. The colder and more dense fluid moves downwards. The circulating stream that rises and falls continuously is known as convection current. Let us look at another example of convection processes in daily life. How does the hot air balloon work? Hot air balloon work because hot air rises. By heating the air inside the balloon with the burner, it becomes lighter than the cooler air on the outside. This causes the balloon to float upwards, as if it was in water. Obviously, if the air is allowed to cool, the balloon begins to slowly calm down. In this picture, who is in the best position? Yes, the cat is in the best position in the cold weather. Hot air is lighter than the surrounding air. So, the cat will get more heat energy because of its position above the dog. Third, heat flows through radiation. Radiation is a process of transferring heat without any medium. Heat can spread through an empty space or vacuum. The types of surface, temperature, and total surface area of an object will influence the rate of heat flow. An example of radiation is when food is cooked in the microwave oven. Here, heat is transferred through radiation. Okay pupils, now let us learn about heat flow in natural phenomena. Have you ever wondered why Earth feels hot during the daytime? Yes, very good. It is because heat energy from the sun is transferred to Earth through radiation. Now, let me tell you about the formation of land breeze and sea breeze. These are examples of natural phenomena using the convection process. During the day, the sun heats up the land faster than the sea. Warm air on land expands, becomes less dense and rises because it is lighter. The cool air from the surface of the sea that is more dense is drawn in to replace the warm air on land. This results in a sea breeze. At night, the land cools faster than the sea. The air above the sea, which is warmer, becomes less dense and rises. The cold and more dense air from land begins to move to the sea, resulting in land breeze. Now, let us learn about heat conductors and heat insulators. What is a heat conductor? Yes, a heat conductor is a material that can allow heat flow. How about heat insulators? Yes, they are the opposite of heat conductors, which means that they are materials that prevent heat flow. Now that you know what heat conductors and heat insulator are, how are they applied in our daily life? Let us take a look at the iron that we use for ironing our clothes. As you can see here, the base of an iron is made of metal to enable it to conduct heat so that our clothes can be ironed quickly. Can you tell me why this is so? Yes, you are right. The bottom of the iron is made of metal to allow heat to flow quickly. Now, let us look at the examples of heat insulators. A chef wears iron gloves that are heat insulators to prevent his hands from getting scalded when handling a hot pot. Some utensils are made of wood. This is to prevent heat from flowing to the hand while cooking. Now, what about the ice box? The wall of an ice box is made of fiberglass or polystyrene, which are heat insulators. This is how the ice box maintains the coolness of substances inside the box. Now, let us learn about the principle of expansion and contraction of matter. We know that the particles in a solid vibrate at a fixed position. Now, when the solid is heated, the particles vibrate faster and move further apart from one another. This causes the volume of the solid to increase because the solid expands. Let us take a look at the experiment in this picture. Heat the end of a metal bar using a Bunsen burner for 5 minutes. Try to fit the hot metal bar into the metal ring. What can you observe? Yes, the metal bar can't fit into the metal ring. Why is this so, pupils? Yes, you are right. This is because solid expands. The metal bar that is heated has expanded, and that is why it cannot fit into the metal ring. Now, let us take a look at the picture. These apparatus are set up to show that heat can cause liquid to expand. We know that the particles in liquid and gas move freely. So, when the liquid and gas are heated, the particles move faster and randomly. The distance between the particles also increases. This causes the volume of the liquid and gas to increase because the liquid and gas have expanded. Now, let us take a look at this next picture. These apparatus are set up to show that heat can cause gas to expand. Here, boys and girls. The balloon will expand in hot water as the particles of gas move upwards. Pupils, from what we have learned today, can you think of how we can use the principle of expansion and contraction of matter in our daily life? Mercury in a thermometer is a heat conductor that can expand and contract. Railway tracks have small gaps between their rails to enable them to expand in hot weather. Without these gaps, the tracks will buckle and overlap. Now look at this situation. This is the use of the principle of expansion of matter. Heat causes the air in the table tennis ball to expand. Let us look at the second example. The pupil wants to open the tight cap of the bottle. The cap can be removed easily by dipping it into hot water for a few minutes. This is because the cap expands when it is heated by the hot water and becomes loose. Well, boys and girls, why don't you try to challenge yourself now? Let us answer the questions together. Number 1. What is the SI unit for heat? Correct. The answer is B, which is joule, and the unit is J. Number 2. What happens to the volume of water when it is heated? Absolutely correct. The answer is B. Let us continue to number 3. How does the air move in a sea breeze? The answer is C, which is wind moves from the land to the ocean. Okay, this is the last question. If the particles of an object are moving or vibrating fast, the temperature would be... Brilliant! Your answer is correct. The answer is A, which is it will be hot. Well, boys and girls, it looks like we are almost at the end of our lesson for today. You are now able to make a comparison between heat and temperature, explain how heat flows from a hot region to a cold region, explain and communicate about heat flow in natural phenomena, communicate about heat conductors and heat insulators and their uses in daily life, explain how heat can cause the expansion and contraction in solid, liquid, and gas. Communicate about the various uses of expansion and contraction of matter in daily life. I hope you enjoyed today's lesson. Goodbye.